Okay, in this section 2-8, we're looking at proving angle relationships. And so last time we looked at proving segment relationships. So now in this one we'll be proving different types of angle relationships. Now, there are several theorems that we want to look at, and these will be theorems that will be used in our angle proofs. And so some of them have names, some of them don't. The first one is called the supplement theorem. It says if two angles form a linear pair, then they are supplementary. So if they form a linear pair, they have to add up to 180. And a lot of these theorems we already have talked about, but we just didn't know that they were theorems. The next one, complement theorem. If two angles form a right angle, then they're complementary. If you've got two angles and they form a right angle, they have to add up to 90 degrees. All right, so the next theorem says congruence is reflexive, symmetric, and transitive. So we looked at the reflexive, symmetric, and transitive properties, but we only looked at it for equality, for equals. Okay, it turns out that these three properties also work for congruence. And now the others don't, but these three do. Okay, the next one, angles supplementary to the same angle or congruent angles are congruent. And so what that means is if you have two angles and they are supplementary to the same angle. So let's say that they're both supplementary to an angle that's 80. Well, they have to be the same because they both have to be 100 because that's the only way they can add up to 180. So if they are supplementary to the same angle, they have to be congruent. Or if they're supplementary to congruent angles, like if this one's supplementary to this angle who's 80, and this one is supplementary to another angle who is 80 degrees, then you know that they have to be also congruent. Likewise, angles complementary to the same angle or congruent angles are congruent for the same reason. And then the last one, vertical angles are congruent. That's a fact that we already talked about. All right, so let's jump into the proofs now. We have some given information. Let's look at that first. Angle 1 and angle 2 form a linear pair, so they add up to 180. Measure of angle 1 plus the measure of angle 3 adds up to 180. And what we're trying to prove is that angle 2 is congruent to angle 3. So once again, we'll start off with the given information. Nobody should ever be stuck on the first step of a proof because you're just writing down the given information. Angle 1 and angle 2 form a linear pair. And the other part of the given information is that the measure of angle 1 plus the measure of angle 3 equal to 180, and that's given to us. All right, so now the next step is to see if there's anything else you can get out of the given information. And so from this statement, angle 1 and angle 2 form a linear pair. Well, remember the first theorem that we looked at? If two angles form a linear pair, then they are supplementary. So the next thing I can get from this statement is that angle 1 and angle 2 are supplementary. All right, and that's from the supplement theorem. All right. Now, from this information, it says the measure of angle 1 plus the measure of angle 3 equals to 180. Well, if these two add up to 180, then they've got to be supplementary. So angle 1 and angle 3 are supplementary. And that's just by the definition of supplementary. If two angles add up to 180, then they are supplementary by definition. All right? Now, look at this. Angle 1 and angle 2 are supplementary, and angle 1 and angle 3 are supplementary. Well, remember we had a theorem that said if angles are supplementary, angles supplementary to the same angle or congruent angles have to be congruent. So since 2 and 3 are supplementary to the same angle, then that means angle 2 and angle 3 has got to be congruent. And that is, when the theorem doesn't have a name, you just briefly state what it says. So angles supplementary to same angle are congruent. Okay, so there you go. And because we're done, because we have gotten down to what they asked me to prove. See if we can do one more here. All right, so on this one now, we have some given information. It says QPS is congruent to TPR. QPS, this one from here to here, is congruent to TPR. TPR from here to here. And what we want to try to prove is these two outer ones. QPR is congruent to TPS. All right? So again, let's start with the given information, and that is that the angle QPS is congruent to angle TPR, and that is by given information. Now, remember what we said in the other proof? Anytime it starts with congruence, we want to change it to equal. So we're going to change this to the measure of angle QPS is equal to the measure of angle TPR. By definition of congruence, and so once again, we want to change it from congruent to equal so that we can use addition, subtraction, multiplication, all that stuff. Okay, now, there's nothing else we can get from the given information, but remember your next step. You want to see what they're asking you to prove and see how you can get these parts into your proof. Right now we have no QPR and we have no TPS. All right, now remember, when we were doing segments, the way we got the parts in there is we used the segment addition postulate. So the way we're going to get the angles we need in here is to use the angle addition postulate. QPR is that piece. Okay, well this angle plus RPS equals to QPS, which by the way is another piece of my proof. So it's helpful to write it in terms of something that's already there for substitution purposes. So my next step is to write out the measure of angle QPR plus the measure of angle RPS is going to be equal to the measure of angle QPS. All right, so once again, QPR from here to here plus RPS from here to here equals to QPS, the whole thing. All right, so what says that an angle can be written as the sum of its parts? Angle addition postulate. Now again, how did that help us? Because now we have QPR in our proof. We didn't have it in there before. Let's get TPS in our proof. Well, TPS plus SPR equals to TPR. So that's the next thing that we're going to write. Measure of angle TPS plus measure angle SPR equals to the measure of angle TPR. And once again, that is also by the angle addition postulate. Okay, so now I've got the two pieces that I want in my proof. Well, what's the problem now? They're in separate equations. I need to try to get them into the same equation. All right, well look at this. Okay, here in statement number 2, I've got QPS equals to TPR. Well, I have what QPS equals to with a QPR, and I have what TPR equals to with a TPS. So since these two are equal to each other, I just need to take these two out and put these two in its place. Then I'll have the parts that I need into the same equation. So again, I'm going to use equation number 2, and I'm going to take QPS out and put what QPS equals to in its place, which is this. So I've got the measure of angle QPR plus the measure of angle RPS equals, now I'm going to take TPR out and put what it's equal to in its place, which is this. Measure of angle TPS plus the measure of angle SPR. All right, so now I have these set equal to each other, and I did substitution here. Took something out and put what it's equal to in its place. But again, how did that help me? because now I have PQR and TPS in the same equation. I use these to get them into my proof, and I use that substitution from step 2 in order to get them into the same equation. Now the problem is I want to set them equal to each other, not with other stuff added to it. So if there was a way I could just make this part magically disappear, that would be great. Well, look at it. RPS, SPR, those are actually the same angle, because remember, you can read the angle from either side. RPS, SPR, it's the same angle. So all I have to do here is subtract angle RPS from both sides. Well, when I do, this disappears and leaves me with the measure of angle QPR. And when I do it from this side, this disappears, leaves me with the measure of angle TPS. And what did I do? Subtract. Now remember what we said when we first started doing proofs? Eventually we were going to do the subtraction and the substitution in the same step. So I didn't have to subtract RPS from both sides and write that out and then simplify it in the next step. I just subtract and simplify it in one step and called the whole thing subtraction. Okay? Now we're not quite finished. I've got to change it back from congruence to from equal to congruence. So I want angle QPR congruent to angle TPS. And anytime you switch back and forth, that's by the definition of congruence. All right, and now we're done. And so like I've said before, I'm not going to ask you to do the proof from start to finish by yourself. There'll just be blanks that you have to be in. Certain statements that are blank, certain reasons that are blank, and you can use the statements and reasons around it to kind of give you a clue as to what should go into that certain blank. So that'll make it a little bit easier for you than having to just do the whole thing by yourself from start to finish.